Welcome and hello. This is a video tutorial in the FHWA hydraulic toolbox. And in this lesson, we're going to be talking about rock sediment gradation calculator. This is a calculator used to help you define and analyze gradation of rock or sediment for design and comparison purposes. It's also pretty much meant for field work. So we're not going to be dealing with any laboratory ASTM sieve analysis tests. We're going to be manually inputting the size of individual particles or taking photos and then comparing those with existing riprap class sizes. So that's where we're going in the direction for this lesson. So let's go ahead and get started. What you see on the screen here is my user interface for the hydraulic toolbox. Here is my project explorer with my project and a few analysis that I've already performed. This one here is the rock/sediment gradation analysis. So this is the one that we're going to be working on in this lesson. This right here is the icon. So you can click on new rock/sediment gradation analysis. So it gives me another one right here. I can just click it to rename. I can right click, delete, duplicate, or rename like that. And I can also add it from the calculators menu by going to new rock sediment gradation analysis or right clicking on your project and new rock sediment gradation analysis. Okay, so I'm going to go ahead and delete those because I only need one. This one's already completed. Let's work on this one right here, rock/sediment gradation analysis 2. If I double click, or you can just right click and then open data. Let me demonstrate that. Right click, rock/sediment gradation. Okay, this is the user interface that we're going to be using in this lesson. Let's break out the user's manual. In fact, if you don't have the user's manual, you can just go up to, let me close this real quick, to the help menu and then hydraulic toolbox users manual. That will open up a PDF. I've already got that queued up. So what we're talking about here is in chapter 12, rock/sediment gradation calculator on page 53. And in certain parts of this lesson, I may just say particles. And when I say that, I'm really referring to either rock particles or sediment particles. Right, so here is the icon for this particular calculator. It looks like a gradation curve, or you could just think of it as an S. And then below that, we have the user interface, which we already saw. We'll be seeing that again in just a moment. And then it has a discussion. So the three main tools here is gradation, where you can add your own gradation just by entering the individual size of the particles. We're not weighing them. Again, this is not a sieve analysis test. There's also a pretty cool image gradation feature where you upload an image and then you specify certain settings and it tells you what the gradation is. And then finally, standard riprap gradation is really used for comparison. Okay, so let's go back to the calculator, right click, rock/sediment gradation, resize the user interface, and let's get started here. Okay, so here are the three options. These buttons is add gradation, add image gradation, and then add the standard riprap gradation sizes. You can also delete an existing gradation and plot all the gradation curves. The gradations that we add are going to be showing up in this list box over here. And then once we select the gradation, it will appear down here. Let me just stop talking and start doing. I'm going to click on add gradation. It says gradation 1. I'll click on gradation 1. So it's selected up here. And then the data about that gradation shows up in this box further below. I'm going to rename gradation 1 just as G1. Okay. And then for the gradation count type, my options are riprap count or stream bed pebble count. Again, these are two different methods to determining the gradation out in the field when you don't have a sieve shaker at all the sieves. It's sort of a field methodology way to confirm or just determine what the gradation is. So the first one here, riprap count, that's a simpler method. It's used for quality control check. It focuses primarily on the D50 size of the gradation, and it uses a smaller sample size, somewhere between 30 and 50 particles, or individual rocks or sediment. It's also used to verify that a riprap matches a specified gradation. Okay? And then the other option is stream bed pebble count. This is a little bit more complete. It's used to characterize the natural sediment size distribution of a river or a stream bed. It requires a larger sample, closer to 100 to 400 particles, and then it also computes the full gradation for sediment transport or stability. So for instance, D16, D50, D84, and so on. All right, so let's deal with riprap count first. So with riprap count, I'm going to click on define particle counts. And then what I get to do here is add a transect, edit the transect, delete the transect, and plot results. Now, transect basically means it's a way to simply walk across the riverbed or sort of do an unbiased sampling of the gradation out in the field. So, for instance, you can take a step and then measure the rock that is beneath your big toe every step of the way and its current orientation. Don't try to like rotate it or pick it up necessarily to get the largest or the smallest diameter. Just go ahead and make that measurement and then do that every step or every 5 steps. It doesn't matter. It's just supposed to be a random sampling. That's considered a transect where you're just kind of moving, at least as far as I understand it. So I clicked add transect. And then, so keep in mind, I'm selected the rip wrap count. When you select rip wrap count, it already provides the set particle sizes. So in millimeters, and I'm not sure why it's millimeters, I'm using English units, but this right here, 76.2 millimeters is 3 inches. And then the next size up, 107.95 is, I think, 4.25 inches. Yes. And then we have 6 inches, 8.5 inches. It increases all the way down to 96 inches. And then this is larger than 96 inches. So it's supposed to increase by approximately square root of 2. And let's go ahead and define that data. So click on transect, click on edit transect. And then in this dialog box, what we're going to do is select the number of points. So this is the number of individual particles that we measure along our transect are sort of a random, unbiased sampling of the particle size. So I'm going to go ahead and say 20 particles for this particular transect. Click OK. Oops. Okay, hold on. I'm not supposed to do that. Let me edit the transect. Okay. Yeah, so all you have to do is click on 20 and then click off, and then you'll get the 20 rows in this table right here. Now, what I'm going to do is type in the data directly. So you can type it in or paste it in. I'm going to be old school and just type in the intermediate dimensions of each of the individual particles. So 7, 6, 8, 8, 6, 7, 9, 3. Okay, so there's 20 particle sizes. I'll click OK. It went ahead and counted up the number of particles for each size and then the cumulative all the way up to 20. So I can go ahead and plot those results. There it is. That's only one of the 2 transects. So I'm just kind of making the numbers up here. But say, for instance, I had a second transect. I'll go ahead and say add transect, select that, click on edit. Okay, let me resize this. Again, I'm going to say I had 20 different particle samples for this transect. I'll type 20. Let me just tab off. Okay, there we go. I have this data saved in Excel, so I'm just going to copy it from Excel and then select the first number here, the first dimension, and then Control V to paste. So that pasted in. Click OK. All right, so we're good there. I'm going to click on plot the results. Pretty much looks the same as before. So I'll close that and click OK. So our gradation for G1 has now been completed using the riprap method. Down here we have some data. So here's our D5, 15, 50, 85, and D100. And we can plot all the gradation curves. Of course, we only have one gradation curve. So let's add a couple more curves so we can plot them against each other. I'm going to click on Add Gradation again. Click on Gradation 2. I'm going to rename it now as G2. Instead of riprap count, let's use the other method, which is stream bed pebble count, and then define particle counts. As before, we want to add a transect, just like that. This is transect 1. I'm going to have 2 transects, but instead of only 40 particles, I'm going to have a total of 200. So for 2 transects, that will be 100 particles each. So I'm going to select the transect, click on Edit Transect. Notice that the particle size are not predefined, and that's all right. Once we add the data will appear in the table here. So Edit Transect. The number of points here, I'm going to type in 100, and then just tab off. And then I've already copied the data onto my clipboard, so I'm going to select the first row here, Control V to paste that data, and then click OK. All right. So here is the distribution right here. Here's cumulative distribution that goes up to 100. And then here is, the size breakdown in the percent finer. Let's add a second transect now. So as before, I'll click on Add Transect, click on Transect 2, Edit, resize that. The number of points, again, is going to be 100. Just click off of that or tab off. Okay. And then paste in the second 100 particle sizes. Okay. Now we have a total of 200. Same size range. That looks good. Let's go ahead and plot the results. All right. And then let's close that, click OK, and then let's plot all gradation curves. Cool. So G1, our first gradation in blue, is right here, and it's a little bit smaller than the one we added after that, which is in magenta. That's our second gradation. So I'm going to go ahead and close that. And now we're ready to move on to the add image gradation feature. That was the main add gradation feature. Now we're moving on to add image gradation. When I click that, it gives me a default name of image gradation 3. I'm going to just change that to G3 and then click on define image gradations. Now we have a different interface because again, we're uploading an image. Number of photos is the first field here. So go ahead and specify however number of fields you have. It'll give you a new row for each image because you're going to browse and upload, and you're going to set up the settings for that particular image, like setting the scale, for instance, cropping, and then after that, you're going to compute, and it's going to create a gradation and gradation curve. All right, so let's go ahead and just use one image because that's all I have prepared. And the first thing you want to do is set the number of photos and then click on the browse button and then navigate to your image. Here's my image. It's just a JPEG I downloaded from somewhere online. It's a bunch of aggregate. I'll go ahead and bring that image to screen. Here it is. So this is looking down on the aggregate itself. In fact, the user's manual does talk about a few different tips for taking photographs of your particles, either your, rocks or sediment. For instance, it says to aim the camera directly at the rock or at the sediment. You don't want to take your photo at some sort of wonky angle because that would distort the size. Secondly, you want a high resolution photo. You want to remove any debris like, I don't know, leaves or twigs or branches or anything that's not sediment. Also, use soft lighting, so direct glaring sunlight from the sun probably wouldn't work as well. And finally, include an object for scale so that you can set the scale a little bit later. So rather than counting or measuring individual rocks or sediment, this feature allows the user to photograph the subject material, provide a scale, and let the image processor determine the grain size distribution. That's what we're doing here. All right, so with the photo uploaded, I'm going to click on Setup. Here is the image, sort of a sample over here to the right. And then on the left, I have my controls. Looks like I can browse to a new image at the top. Set scale, that's the first control. And it's kind of hard to see, but there's a line segment right here, which allows me to move the handles to specify the size. So if I happen to have a ruler kind of in the corner of the image, then I could resize this to the ruler and then set the value in inches. I would just say, oh, it's 12 inches, or it's about 4 inches from here to there. So I'll say that's 4 inches. Maybe it's not, maybe it is, but I can come back and change the scale later if I'm not satisfied with my results. After that, we can go down to the next feature, such as set cropping extents. So you can click on that, and then you can resize this image just by clicking on the handle and cropping out certain parts that you may not want for whatever reason. Perhaps your ruler was in the corner. You don't want that to be counted as a particular particle. And then a few other features here, such as cropped image, 8-bit image. I didn't go through these. The user manual doesn't talk about them either, but knock yourself out if you wanted to investigate those. The last one is important. This is results. So click on results. It's calculating. Boom. Here's our grain size distribution. We have the size, particle size in millimeters. We have the individual particle count for that size, and then the cumulative count and the percent finer. So this is the exact same table that we saw earlier, except it was generated automatically based on the image and the scale that we provided. So let's just go with that. Let's actually plot the results. Yeah, of course, it looks a lot more natural and a lot larger range of sizes than the previous two gradations, but we can compare them now. So let me close this and then click OK. And you can see the red lines are kind of outlining the different particles identified by the image processor here. So if I didn't like that for whatever reason, I wanted to change the value or change the scale or use any of these other features, you're welcome to do that to get it just right. And then again, click on results for it to recalculate. Okay. So you can click previous or next if you had multiple photos. I'm just going to click OK, return to this screen. If I had another photo, I could add it. but I'm happy with what we're dealing with here. We have the results D5, D15, 50, 85, and 100 are listed right here in millimeters, and that's we're good to go. So I'll click OK. So we have our G1, 2, and 3. I'm going to click on Plot All Gradations. So G3 is actually our smallest. That's the red line. G1 in blue, that's what we did first, and magenta was G2. We did that second. All right. So the final part of the lesson is the third option to add a standard riprap gradation. And this is really for comparison purposes. So I'll do that. And then riprap 4. I'm going to rename this and call it G4, but I'm also going to say dash class 5. I'm just kind of picking a random class number. So riprap class, our options are between class 1 through 10. And then there's also user defined. Let's click on class 5. And then the class 5 is going to have an upper range and a lower range. So the upper range of data is right here. It's our D15, D50, D85, and D100. Here is the size in millimeters. And then the lower range is right here. Again, D15 through D100. So with the lower range and the upper range, if I click on plot gradation, it's not a single line, but it's rather a range of sizes for D15 all the way up to D100. So we can very quickly use this tool to take a photograph or do our manual counts, enter that data into this tool as a gradation, and then compare it with the different classes 1 through 10 of standard riprap. So let's go ahead and now click the plot all gradation curves. And in yellow is the new curve right here. This is that G4 gradation for riprap class 5. So this tells us immediately that none of our gradations fall into that category for riprap class 5. They all happen to be smaller, probably class 1, 2, 3, or 4, or maybe neither at all. So let's go ahead and do one final example of a standard riprap gradation. That was G4. I'm going to click on Add Standard Riprap Gradation. This one right here, click on it to edit. And then I'm going to rename it. I'm going to say G5. And then I'm going to call this class 2 now for riprap class 2. Again, I'm just guessing something less smaller than 5. I'm going to click on class 2. I can look at the upper and lower range again. I don't need to do that. I'm just going to come straight to plot all gradation curves. Okay, interesting. So class 2 is this light blue cyan color. It appears to be smaller than magenta, but larger than the blue gradation. Magenta was G2, the blue gradation was G1, and then G3, the one with the photo, was way too small for the standard class G2. Let me go ahead and make an edit to that real quick. I'm kind of curious. So add image gradation. Oops, I don't want to add. I want to select that, delete. I want to edit. So G3, okay, define image gradations. That's what I meant. And then we've already done this once. So let me just click on setup. Instead of 4 inches, let me go ahead and say this is about 8 inches. I think that's right. Click on results, let that run, click OK, OK, and then OK, and then plot all gradations. Okay, so the red line moved up a little bit closer. It's still the smallest of all of my gradations, but it's a little bit closer to the class 2 and class 5 and the 2 manually defined gradations. Well, that's it for this lesson. What we talked about was the rock sediment gradation calculator, where we added a gradation, added an image gradation, and then added a standard riprap gradation for comparison.